We have finally made it to what might be the end of this inventory course. So today we're going to take a look at saving out our inventory and being able to load it back in. Because of course, if you have an inventory, you'll want to be able to save and load what's in it. Otherwise, there's not really a point to introducing it into your game, is there? And while we're at it, we're also going to just touch up a little bit about the equipment slots so that they can actually be saved and loaded as well. At the moment, they work, but they're a little iffy in some ways. So let's take a look at how we can get started with saving and loading. We have our inventory component, which has a bunch of functions on it, but all those functions really only serve one thing, and that is setting up our inventory array. Everything else is to serve the inventory array. So this is a thing that we're going to need to save. And the inventory array is an array of a struct that we have made. And that would be this inventory slot. So we're going to need, for every inventory that we have, every inventory slot, we're going to need to save the has item and the stack size, both of which are going to be easy. It's just a bool and an integer. But then we get to the item asset, which is a reference to a, well, item asset. And we can't just save references like that to a save objects, because this isn't a real value. This is a place in your system's memory. And if you save this, then close the game and start it back up, the asset is going to be in a different place in memory. Potentially even throughout your playtime, if you unload this asset for any reason and then the engine loads it back in, it might be in a different place in memory. So you can't just say, hey, save this and we'll go from there. So we need to somehow save out the item asset as something that is not a direct reference. We'll take a look into how to do that in a moment. The index, of course, is just an integer. We can save it out. And the metadata, we have a similar problem to as the item asset. Because it is an object reference, it is just a pointer to a place in memory. So we can't really save that. On top of all that, metadata, the whole point of this is that it could contain a whole bunch of different types of data, depending on the type of metadata objects that we're assigning to this. That's why we made the entire metadata system. So how in the world are we going to save out something that we don't know in our code what is actually going to contain? We can't very well make different save objects for every single type of metadata objects that we could potentially be saving, because that would just be a pain. That wouldn't work very well. So we need to serialize this into a format that we can easily read and write from and to. That is the basic overview. Let's actually just get started doing it now that we know what we have to do. So we're going to make something in either the game mode or the game instance. Wherever you prefer to put this, you can put this. You could even make it into its own game module. So it's a little bit more plug and play if you want to put it into different projects and stuff like that. For now, we're just going to go and make a blueprint class for the game mode base. That's just the easiest place to put this. So let's call this game mode inventory, something along those lines. Now, it is important, if you do this in the game mode or in the game instance, to go into your project settings and look for your game mode. The default game mode we should set to the one that we just made. If you did it in the game instance, of course, you need to set the game instance class to whatever game instance you just made. Either or works. So let's open up that game mode. Before we forget, I'm going to set the default pawn back to the third person character. Otherwise, it's not going to be spawning in the default pawn there. Everything else we can keep the same for now. And here we can start making some new functions as well. So let's make a save inventories function. And while we're at it, we might as well make a load inventories. And I'll just get started with these save inventories. So we're first going to check whether a save game already exists with a given name. You can just put in the name directly here. We're just going to make that a parameter because it's easier to set up and have multiple save files that way. So that'll be the save game name. And then we put in a branching node. And if that already exists, we're going to load that save game. If it doesn't exist, we're going to create that save game. So does save game exist? Yes, we're going to load game from slot, and the slot will just be the save game name, which we can just get save game name because it's a local variable as an input parameter. And if that is not the case, we will create save game object. And the save game objects that we're going to be creating will be of type, we still need to make that class. So let's go ahead and make that class now. We can just make a new blueprint class. We'll look for our save game as the parent class, and we'll call this SG for save game inventory, something along those lines. And here we're starting to get to having to make some new stuff. So we only really need to put one variable on this for now. Of course, if you have a game with a lot more stuff that you want to save than just the inventories, everything you want to save is going to exist in this save game class. But for now, this will just be the inventories that we save. That's all going to exist in this one variable. And the variable is going to be of type string. And we're going to make that a map. So the string will be the key. So we can give in a string and it will give us the corresponding saved inventory. Of course, we do need to make a struct that contains our saved inventory. And for that, we're going to need to make a struct that has an array in it of inventory slots, but not just normal inventory slots. Because of what we just talked about, we can't save everything in a normal inventory slot. So we need to make a specific struct that will store everything in a savable format. And then we're going to be saving an array of that in our save inventory struct itself. If that confuses you, don't worry, we're going to go over it one step at a time. So let's get started by making a new blueprint structure. And this will be the str for struct inventory slots save data. And if we open that up, we can, as we discussed, just put in the has item. The stack size, we can also just put in, that will of course be an integer. And then we can add in the item assets path instead of just having the item asset reference itself. So what we're going to be doing is we're going to be saving the path of the item asset, so where it exists in our project, as a string. So that way, when we get an asset, we can get its asset path, save that. And then when we need to load it back in, we can use the asset registry to get the asset from its path and load it back into the right place and do it as we need to do. So then we have the index, which of course is just going to be a simple string. And then we get to the metadata. And for that, we're going to need to do a couple of funny little things, but we're going to be storing those as strings as well. We need to set up something to serialize this. Again, into a way where we can put pretty much like arbitrary data into a string, and we're going to be putting it into a string array so that we can also read those back. And strings are just very, very useful to put arbitrary data in, because you can literally put anything into a string. And then you can read those back and do with that as you want to do in your code. So this will be our inventory slot save data. And then we make a new struct as well. So we're going to go into blueprint structure again. And this will be a str inventory save data. This is going to be for the entire inventory. And all that this will be is our slots. So this is going to be the inventory slot save data, and it's just going to be an array. And the reason that we do that in a struct is that this is the only way in Unreal Engine to make a map that has an array in it. Unless you're doing C++, in which case you can just make a map with an array in it, but Blueprint doesn't allow you to do that. So this is a little bit of a workaround for that. I do feel the need to point out that you should try to avoid doing this, however, in actual gameplay. We're doing it here for a save system, so it's kind of fine. But doing an array inside of an array, like these nested arrays, if you can prevent doing it and do something a different way, it is better, because this is a nightmare for your CPU to look up all over the place, because this is gonna not be efficiently stored in memory. But since we're only saving and loading this stuff as save games, it's not that big a deal here. Anyway, back in our save game, we have our string map, and we're going to put in our inventory save data. So not the slot save data, but the inventory as a whole as the save data. So now we can just give it a default value just to show you don't need to give it a default value. And after you do this, you do need to make sure to remove it again, but we can give it a name. And then inside of this, we have all the different slots, which have all this different data in it. And we're going to be populating that, of course, programmatically. So back in our game mode, we finally have our save game class. That took a little bit of time to set up, I know. But we can now say, hey, our save game inventory class is what we're going to be constructing if the save game does not already exist. And we will promote that to a local variable and call that something like save game. And then we also want to be able to set that save game after loading it. You'll note though that we can't immediately hook this up because this just returns a generic save object. So we want to cast that to our save game inventory, and then we'll be able to set it as our local variable. Now that we have our save game, the very first thing that we're going to do is we're going to get our inventories map, and we're going to be clearing that. Because sometimes it does a bit of a weird thing where if you try to override a slot with an item in it with a empty slot, so you want to clear out the slot itself, it kind of it gets a little bit confused. So the easiest way to fix that is just to clear the entire inventory array, because we're going to be making a new one here anyway. Now, the question is, how do we get all of the inventories in our game to save? Because it is pretty easy to just hard code, get your player character, get the inventories out of that, and just save that. But we, of course, also want to save the inventories from all of these things. So how do we do something that scales up easily and doesn't require us to go back in here and say, oh, yeah, actually, I also want to save this object, and across like a billion different levels, all these objects. That's just going to be a pain to deal with. So the way we can easily do that is with get all actors with a tag, and then we'll simply give a tag to everything that has an inventory. So we will, I just have this as a string copied over here. I will just give it the tag inventory to look for. And the neat thing is, if we go into the inventory components, into the event graph, which is still empty because everything exists in their own functions, we can get the owner of this component, which gets us an actor, and then we can get the tags on this actor, and we can add a tag to it, and that's going to be the inventory tag. And now automatically anything that has an inventory on begin play will be given the inventory tag. So we can test that by just playing, and let's go F8. Our player, of course, has like 3 inventories, as a matter of fact. So we look at its tags, and we can see it has inventory 3 different times. That doesn't actually matter that much, doesn't do that much. I guess what we could potentially do if you really wanted to, you could check if it already has this. So you can use the find node here and try to find inventory, and if it is greater than 0, that means it's found one and it doesn't need to add it again. If it doesn't find the inventory tag in the tags array, this will be -1 as an output. So if we just connect this up to a branching node, so only if this is not greater than 0 will we add the inventory tag. I guess the other way to do this is just to check whether or not this is less than 0 and then use true. That might make a little bit more sense. Depending on like how your brain works, you can do like one or the other. It doesn't really matter. Like less than and not greater than are effectively the same thing in this case. So now we'll see if we go in here, we should only have the 1 inventory tag because it only adds it once. Again, there's not really an issue with it having 3 of the same tag in this case, but maybe in some other piece of your code that would matter. So it's better to just set it up to only apply it once. And all these things that also have inventory components also have the inventory tag now. So if we go back into our game mode, when we get all actors with this tag, it will get us an array here with all those actors that have that tag. So on that, we can do a for each loop because we're going to need to loop over every single one of those. And first and foremost, we're going to get the inventory. And that's the interface that we set up a while ago that provides its own inventory components through this interface. And if it has more inventory components, it provides all of those as well. So as an example, if we go into the third person blueprint here, it has the interface for get inventory, and it gives its own inventory component on the top here, but it gives its inventory component and the hotbar components for the array here. And we haven't actually added the equipment component to that yet since we've added it. So we also should be returning that. So first order of business being checking whether or not the actor that we're trying to save the inventory of has more than 1 inventory. So if we have the length of this array be greater than 1, so greater than 1, we know that it has multiple inventories that it is returning, which means that we need to do something slightly different and slightly a little bit more complicated in a moment here. But for now, let's focus on just saving out the one inventory. And we're going to be doing that with its own function, actually, because we're going to need to hook up that function to both of these things. And we'll call this one save inventory, singular, instead plural. And here I'm actually, to prevent any confusion, we're going to go up to the access specifiers and we're going to set this to protected. So this way, if we make a child class of our game mode, we can still run save inventory if we really need to. If you don't want that to be true, you can set it to private as well, which in this case might be preferable anyway, to be honest with you. So yeah, let's actually set it to private. But if you set it to protected, it will still be accessible through all of its child classes, but other classes will not be able to access it. So unlike the save inventories function here, if I go into my third person character and I try to access this from like that game mode and I cast to the proper game mode class, I'll be able to get the save inventories and load inventories. But even though save inventory exists on here, because it is protected or private, it won't be able to be accessed from other classes. This is just to prevent confusion, since we have save inventories plural and save inventory singular as two functions under each other when we look this up. I don't want people getting confused and accidentally only calling the normal save inventory function, because this function never needs to actually be called outside of the context of from where we're going to be using it here. Anyway, that's a very long-winded explanation of access specifiers. We need to put in a couple of inputs here though. The first thing that we're going to need to input is the inventory component that we're going to be saving. So let's do inventory components, which of course is going to be of type inventory components. Then we need to specify the owner's name, because that's how we're going to be saving and finding these things. Since we have a bunch of different inventories that we're going to be saving, we have that map on our save game object here, which has a key for a string. And that's going to be the owner's name. So that way, when we load these things, the names are going to be consistent between play sessions, because those are just baked in when you place them into the editor to begin with. So we're going to set the owner's name as the key, and then we can look up the saved inventory component in our save data by providing in the actor's name again. And then we also want to provide in a reference to the save game. So that will be of type save game inventory, of course, and that'll be all the inputs that we need. So from our inventory component, we're going to get the inventory array that we have. And I won't surprise you to see that we're going to be doing a for each loop over that, because we need to loop over every single inventory slot in there. And we'll pull off of the array element and break it, because we're going to need some parts of these outputs to construct our save data. And the way we'll do that is we'll make a new array here, and this will be the saved inventory slots, and that will be of type inventory slot save data. So this time it is the individual slots that we're saving to an array, not the entire inventory save data. So just the inventory slot save data, which is going to be an array. So now that we have that array, we can start adding to it. So let's drag that in. Again, it's a local variable, so every time this function will be called, it will create a new fresh empty version of it, and we will add to it, and we'll just split the structure pin and start hooking these things up. So first and foremost, we get this item asset and we check if it is valid, because if it is not valid, it is an empty slot to begin with, and we don't really need to worry too much about any of this. So if it is not valid, has item will be false. Stack size will be false. The item asset path will be nothing. The index we do actually want to set properly, just because, well, it is the index value. And then the metadata can be empty as well, because if there's no item, obviously there's not going to be any metadata. The actual difficulty comes in when we start adding it in when there is an item, of course. So when is valid, we have a different adding node. And here we can pull through most of this. So we can do a has item to has item, stack size to stack size, index to index. But now we need to get the item asset to the item asset path, and the metadata to a metadata string array. So let's do the easier one of the two first, because we can literally just pull up the item asset here and we can get the object path as a string. So get object path string, and we just plug that into the item asset path. That's honestly as easy as it's going to get. That now saves the path to where this asset is located. Do be aware, if you are actively developing your game and you change where that asset lives in your project, like folder structure, this will no longer be able to properly load because it is physically looking through your folder structure to find the asset in a specific path. So if we go into my items and item assets, if I make a new folder and I put like my armor into that folder, if I then try to load in an inventory that has like armor pieces, it's going to try to just get them from this folder because that's where they lived when I saved this. But of course, if I've changed that, it's not going to be able to load them in at all. So do be aware of that. Now, the metadata. This is the fun bit. It's always the metadata that kind of throws a wrench into things, isn't it? Let's go into our base metadata object. So that should be somewhere in here, BP metadata. And he'll add two new functions as well. So we will add a get data as strings, and we'll also make a set data from strings. So as you can probably tell, what we're going to be doing is this one will get the data as an array of strings. So we will make an output, and that output will be just called data, and that will be of type string array. And we'll create a local variable here, and we'll call this data array, which will be of type string, and of course it'll be an array. And all that we need to do here is we need to just get this array and we need to add something to it. And what we're going to be adding will be, in this case, just our counter variable. This is just the thing that exists on our base metadata class that we don't really do anything with. It's just for an example, but it serves as a good example here as well. So it'll take this integer and turn it into a string. So it'll just say the numerical value of what this is as a character and add it to this. Then once we have done that, we can get our data array and return that data array value. So if we just have a base metadata object with nothing else on it, this array is going to have one index with the value of this counter. But if we go into the metadata for the weapon, we have also the enhanced damage level and the durability and the max durability. So what we end up doing is we go into the functions here and we override the get data as strings. First thing we do is we right click and we add a call to the parent function here. And we might need to make sure that we compile the parent class first as well, if you don't have that yet. And this will just run this code before we add on some extra code of our own. So that also gets us easy access to this local variable that we have here. So we can just add a couple of adding nodes to this, 3 in total, as a matter of fact, because we've got 3 extra little bits of data to add in. So let's connect all of those up and let's make them look a little bit neat, because God knows I'm eventually going to have to do this for the Patreon download. And then we can just drag these in. So enhanced damage level, and then the durability, and then the max durability. And so it will first run the parent version of the function. So at index 0, it's always going to be putting in this counter. And then we will always know that consistently at index 1, we'll have the enhanced damage level. At index 2, we'll have the current durability. And at index 3, we have the maximum durability. And then if we even have a child class of this metadata for the weapon, like specifically for like a sword, we know that the next thing that we can add in will be at index 4. And 5 and 6 and 7, and if we then have yet another class that is a child of that, we can keep counting up and counting up. There is a little bit of iffiness here that you as the programmer need to be aware of how many things precede any given metadata object with how much data is getting added to these strings. Just adding it doesn't matter, but when we start reading it back with the get data from strings in a moment, you need to know at what index every single piece of data lives. Because after they've been saved, they're just strings. We can't like really filter on anything anymore. Anyway, here as well, of course, we add a return node and we return that string array. So that is the getting data from strings, and that's all that we need for now for saving things. But now that we're in the metadata object anyway, we might as well also do the setting from the strings. So this will instead take in a data array of strings, and we'll do more or less the opposite. So we'll set the counter value to getting a copy, and here we need to know the exact index of where the counter value is going to be stored. So we know that's always going to be 0 in this case, because it's always the first thing to run. And you can locally just say, hey, get this string and try to put it into an integer. If you put in a string that is not a number, this might have some wacky results, so just don't do that. And then in the metadata weapon, we can also override set data from strings. And here it will also first call the parent version of the function, if you have one. And then we can just set these three in order. So we'll just get a couple of getting nodes for this and all hook them up to this. And here we know, okay, so we set these in this exact order. So this one first, then this one, then this one. We already had index 0 used up by the counter in the parent here. So we know that we're going to need to get this from 1, 2, and 3. And we just connect these up. This is a little bit tedious to set up anytime you make new metadata, but for the most part, like once you have your metadata objects set up, there shouldn't be much reason to change this around much, so you don't really need to like worry about like working with all this too much. And that is how you set a read from that metadata array. Now we can finally go back into our game mode again, into our set inventory, the singular one. And now that we can get the metadata from our metadata object, we can get data as strings. We just hook that up here in the isValid node and then to the add, and we just provide it with that metadata. And then when all of that is completed, so when the for each loop is done and has gone over the entire inventory array, you might be thinking we haven't used the owner name or the save game yet, and you would be correct. So we're going to get this save game and we'll get the inventories map that we have, and we will add a entry to that. The string is going to be the owner's name, and the input here is going to be our saved inventory slots, because if we see this as our saved data inventory structure, that only had an array of these things in it. You can't quite like just put this in directly. It's not quite how that works, but we can just make one. And all that it takes to make this kind of struct is just an array of these ones. So that's how we can put that in. And then we just hook that up to on for each loop complete. And that will add this inventory that we're saving to our save game object. So let's go back into the save inventories, like the grant parent function that we have here. It's not quite a parent, but like the function that we'll be calling the save inventory function. And first, the easiest, because we were checking here, get inventory, whether or not we have more than one inventory that we're returning from this interface. If not, we're only ever saving one inventory on this thing. That is the easiest situation that we can find ourselves in. So we can just save inventory, the singular one, and we can just get that inventory component. We'll always know that, hey, if we're not returning more than one inventory here, we'll just use this bin if you have all of your implementations set up for this interface properly anyway. Then we will get the actor out of our for each loop. If you remember, we have all actors with tag that we're getting here. We're doing a for each loop over all those. It's been a while since we've actually set that up, so I'm just reminding you. And we can just get the display name from that, and that will be the owner name that we put in here. And then we have our local variable for the save game that we can put in just like that. And this is how saving singular inventories works. So if you just have things with only one inventory per actor, this is all that it takes to save these things. But of course, our character has 3 inventories, one for the inventory, one for the hotbar, and one for the equipment. So if any character in your entire game has more than one inventory, we're going to need to set up just a couple more nodes here. So if we do have more than one inventory, we do a for each loop. And what we'll do is we'll go over the entire array of inventories that we're getting provided with. And each one of those are going to run its own save inventory function. This is an array of just inventory, so we can just immediately put the array elements into the inventory. The save game will still just be our save game local variable that we have here, but the owner name is going to be the thing that is a little bit more tricky, because we're going to get the display name from the actor that the array exists on. So we have an actor that has inventories, and then we're doing this loop over the inventory. So we're getting the display name from that actor from the first for each loop. And we're going to be appending something to that. So we'll have the display name of the owning actor. and then we'll just add the array index to it. This way, every single one of these inventories still will be able to be recognized with what actor they exist on. And since this always gives you an array in the same order of indexes anyway, we can now differentiate between different inventories on the same actor. So the owner name for the character will just be like player character 0, player character 1, player character 2. And that'll be the 3 different inventory components on our player character. And once that all is done, we go back to the for each loop, the first one here, for the get actors with tag, and we finally save game to slots. And we'll be saving the save game object that we've been working with, and we will save those to the save game name. As you remember, that is the input parameter that we have over here. And that's only the saving half of things. Don't worry though, while building up this saving half of things, we set up a lot of stuff like all these different classes and these new structures that we're using. The loading half of things is actually going to be significantly easier now that all the pre-existing functionality has been set up. So let's go into load inventories. And here we also check, does save game exist? We're going to be checking the save game name, save game name. This is actually a lot easier because if this does not exist, we just don't do anything. Because if the save game doesn't exist, there isn't anything to load. It's just as easy as that. So false, we just don't do anything. If it is true though, we load game from slot. And we're going to be loading the save game name. This will give you a return value of a generic save game object. So of course we need to cast that to our save game inventory. And then we can promote that to a local variable. We'll call that save game just like before. And once again, we can just get all actors with a tag. And I'm going to, just to be sure that we are using the exact same thing, I'm just going to go over here and save inventories and just copy over and paste. Don't want to have any typos just sneaking in there. That would be bad. And we can, once again, go over a for each loop with all the actors that we find. And here we do something very, very similar. When we find an actor, we get its inventories with this message, just like we did before. We check the length of this array. We check whether or not that is greater than 1. We put that into a branching node because if it is greater than 1, we need to load in multiple inventories. We'll set that up in a moment. But if it is not greater than 1, it's just loading in 1 inventory, which is quite simple. So I guess you know what is coming now. Just like we made a singular save inventory, we're going to make a singular load inventory as well. And this one also will require similar inputs. So first and foremost, we will put in the inventory components, which will of course be of type inventory components. Then we'll put in the owner's name, which of course will be a string. For this one though, we don't just want to do the owner's name. I'm also going to put in a name suffix. And this will be the 0, 1, 2, 3, 4, whatever we want that we put in with the saving. We're going to be combining those things back together inside of this function. So if we only have one inventory on a character, this name suffix is just going to be empty. But if we have multiple inventories that we're loading in, we're going to be putting in the index of another for each loop just for this name suffix. So then this will combine back into owner name plus suffix, which will be the exact same thing that we put in when we were doing the actual saving. And then of course we also need the reference to our save game object, which will be of course our SG inventory, and that's all the inputs that we need for now. So having our save game object here, we can get our inventories, and then we try to find an inventory based on the combination of these two things as the name. And that's going to be returning us with the inventory corresponding to that actor, and specifically even to like the exact inventory on the character that we're looking for. So we can break the output from this to get the individual slots as an array. And of course, we're going to be for each looping over that, because that's just what we do. We do that a lot in this video. And the very first thing when we load in an inventory slot to do anything with, we want to clear that slot just in case anything exists on it. So we just get the array index, put that into the clear slot index, and we clear the slot because we're going to be repopulating it with the saved item in a moment anyway. And then let's get our inventory component, which you actually can just like get inventory component, because again, you can get these input parameters as local variables. We'll get the inventory array, And we will set an array element. And we're going to be setting these things manually bit by bit. So we'll split the structure bin open. So of course the index of the array as well as the item index here are both going to just be taken from the array index in our for each loop. And then we get the array element itself from the for each loop, which again is going to be the saved data from the inventory slots that we saved. So we can break this open and we can see that this has the has item, the stack size, the item asset path, and the metadata, because that's how we save things. So obviously we can just pull through the has item, we can pull through the stack size, and we could pull through the index through here as well if we wanted to, like same difference, honestly. Now though, getting the metadata back in there and getting the item asset path to load the proper item in there, that's the slightly more tricky part. So let's do them from top to bottom. So first, item asset path. What we'll do is we will get the asset registry, and this is just a general function to get a reference to Unreal's asset registry. It's very descriptive in what it does. And when we have the asset registry, we can get assets by object path. We're going to be using the singular version. You can also get multiple assets by object path through this. So if you just put in a folder, it'll give you all the assets in that folder. We just want to get a singular asset in this case, so we're going to be using the top one. And the object path will be our item asset path. And in our case, we don't need to include disk-only assets because these data assets will live in memory, not specifically on the disk. So when we get that, we get this structure that has the asset by object path, which is not that useful. But from that, we can just simply get the asset, and it will give us the asset as a generic object reference. As you can see, we can't put it in there yet. So we just need to cast that to our BP item. And if that cast succeeds, then we can put that back in there. So that loads in the item assets again. And now all we need to do is load in the metadata. So in order to load in the metadata, we do that after we have the item itself. And we construct an object from class like we did before. And then from the item, we get the metadata class. And we're going to be constructing an object of the corresponding type. The outer, we just get player character again. Once again, you can very much upgrade this to have its outer be the specific inventory component that it belongs to. But that makes switching between inventories a little bit more tricky. After we construct the BP metadata, we can set data from strings, because that is the function that we made a while ago. And the strings that we take in will just be like this metadata strings that we're getting from this break, from the for each loop. We can just provide that in. And then we also, coming over the construct BP metadata, just provide that in as the array element here. And with all the noodly goodness, that is all there is to it to make you load the inventory. Once all that is done, we simply get our inventory components. So we can just get inventory components, and we will call inventory changed because we've just added a bunch of stuff to the inventory, and we want to be able to like visually reflect that. And that's how our inventory widget works. It works on this event dispatcher. Now we have the load inventory function ready, and now we can implement that in our load inventories function, the plural one, in much the same way that we did for saving. So if the length is not greater than 1, it's just simply one inventory that we're loading onto this one actor. All that we need to do is we need to pull over here, load inventory, and we just put in the singular inventory components. We get the actor from the for each loop. We get the display name, simply put that into the owner name. Since we're only loading one of these things, we don't need to provide in a name suffix. And the save game that we'll be working with will of course be just save game. If however we have more than one inventory that we're working with, what we're going to be doing is of course we get the extra int array and we do a for each loop over that. And we take the array elements, goes into the inventory component. We get the display name here, and we give in the name suffix as this. You could, I guess, also do that outside of here in the same way that we did with the saving. That would work just as well. I just wanted to show you like both versions, I guess. But for the sake of consistency, you might want to update one or the other so that they both use the same method of either taking in like the name and the suffix or doing it like outside of the function, like in here with an append node. That's entirely up to you, what you prefer. Of course, we put in the save game just like that, and then we loop through. It's really quite straightforward once we have the function itself set up. And now we have saving and loading of all our inventories in the entire game working. If we go into the third person character here real quick, and I add in, we have this debug F key. Let's also add in a debug G key or something like that. We can get the game mode, cast that of course to our game mode inventory real quick. We'll do that for both of these, and on pressed for one of them we will save inventories, and you can see we only have the save inventories. We don't have the singular one, only the plural one, because we set that to either private or protected. What you will note, however, is if we try to load the inventories, I didn't mark the other one as private, so we can access load inventory by itself. You don't want that confusion, so we're going to go back in and set that to private in a moment. So we'll load inventories, and we'll just call this like save, that we're going to be saving and loading this to. Of course, if you have a whole save system and stuff like that, you can make this a variable and do like fancy stuff with that. I have separate videos on save systems. And do make sure to check whether or not your game mode override is set to anything, because right now it's still overriding this as third person game mode. So that cast is failing. I had a little bit of a weirdness about that, so I needed to test that. But just make sure that you don't do that. And if we pick up some items now from here, let's also pick some items out of these chests that I put them in, something like that and something like that. We have a bunch of items in our inventory and a bunch of line traces all over the place. Open my inventory up. Let's move some items around a little bit. Save our inventory with the F key and move them around a little bit more. Load our inventory back in, and you can see they snap back to where I saved them. And now let's take out these items as well. And now I will load the inventory again. And you can see the items will disappear from here and they will be back where they belong in the chest. So everything works more or less perfectly, again, except for the whole equipment thing, because that doesn't properly update its inventory component yet. This video is very long as it is, so we're going to go through that very quickly just to wrap things up real quick, because you do want to set that up properly. And if you're getting errors like these, by the way, access on trying to read inventory component in a couple of different places, you might want to, in both the save inventory and load inventory, just put in a quick is valid. And note, this shouldn't change anything about the functionality, because it's being an issue anyway. It's not going to crash your game, but it will prevent you from getting these error messages. Equipment slots, while they work perfectly fine for putting things in and visually displaying it and having the data in them, they don't seem to yet be updating the corresponding inventory components, so it doesn't actually get saved through to there. That is a pretty quick fix though. So let's dive right into there. We'll go into the inventory folder here. And I have this player inventory where these are just like loose empty inventory slots, and we need to like set up some stuff for that. So we at some point started building in this on item changed for specifically the weapon slot, and then didn't do anything with it. So now we're going to do something with it. That something will be not quite here yet. We're going to be using this exact same make array that we have that we're setting the inventory components on each of these slots with. And we're going to be looping over them a couple of more times. And since we're looping through the same array anyway, we might as well get rid of the sequence node here and just do everything there in this for each loop, just so that it's a little bit less messy with a bunch of separate loops doing separate things. So the first thing that we're going to be updating here is in the inventory slots. At no point while creating this do we set the index in it. So first things first is we want to set member, and then we can come over here and set the index. So this will just set the index to the for each loops array index. That fixes issue number one. Then we also want to, for every single one of these, assign on item changed. And at no point are we actually calling this. We'll set that up in a moment. We'll call this item changed. And when the item changes, we need to do some stuff. So let's go back into the inventory slot and set up a couple of little changes there as well. Because we have this on mouse preview down thing, we have redraw item slots in like a bunch of different places here. We can actually get rid of all of these because we're going to be doing that through the event dispatcher next. And instead, we will call item changed. because whatever happens, like whatever path we go down here, the item will have changed. There will be a separate like new item or like a new value of an item or whatever in that slot. So whatever happens, we always end up with on item changed. And the on item changed event dispatcher that we have up here is actually going to take in a new parameter. And the parameter that it will take in will be the updated slot, and that will be of type WBP item slot. So now it has that as a parameter, and we'll just get that a reference to itself because this thing itself is what was just updated. Down here, when we clear the inventory slot, we set the inventory slot to being entirely empty. Obviously, we don't want that, because we still want the index to be properly assigned. The has item and stack size and all this can be default values, but we should remain with a properly set index. So we can just get the index from this break node over here and put that into the inventory slot there. So now that we have that fixed up, that's going to prevent some other issues in a moment. We can go back into the player's inventory. So that's this widget over here. And this item change will now have the corresponding like input parameter that we can actually start doing stuff with. So when we do this function, we're going to take this array and we're going to be finding the slots that this corresponds to. So just finding the slot that we just changed in this array. Then we will take the player's inventory equipment component. We will get the inventory. And we will directly just set an array element. This is just a like brute force way to make this work. Again, we don't have a very like modular and procedural way to deal with these inventory slots because they're pretty one-off. So a lot of this is going to end up being more or less just hard code. We'll make the item slots here and we will get the inventory slots from the updated slots. We can just split that. Has item can just be pulled through, stack size can just be pulled through, item asset can just be pulled through, and the slot metadata can just be pulled through. Index, you might be able to pull it through as well, but that's why we did this finding thing. This is just a little bit more secure, and I've had so much trouble with this system. There's a little bit more secure method, just helps solve potential like edge case issues. And we'll also do the same thing with hooking that up to the actual index for the set array element. Once that is done, we'll use the player equipment's inventory and just call inventory changed, which brings me to the next thing. So let's put this back with a sequence actually, because we do need to put this in like a separate little thing. And we're going to get our player equipment inventory and we will assign inventory changed for this, and we'll hook that up into our sequence node before I forget. And we'll use this exact same array here to make a for each loop again. Anytime we go and update the inventory, we want to just kind of like redraw that item slot. So we hook this up, we get the inventory array that we have, then we get a copy of whatever index we're at when iterating through, and then we can set the inventory slots here to whatever we get in there. So what this will do is it's kind of circular what this does, but it will make sure that everything is 100% the same between what the inventory slot shows and what is actually in it. Because this side over here is taking what the item slot has in it and then setting it to the array element. And then this is taking that array element and setting it back into the slot. This step might not be entirely necessary, but once again, this entire equipment system's given me such headaches that I just built this in as a little bit of security. Anyway, once we have done that, we can just redraw the item slot for all of them. And that should now allow us to also functionally have our equipment sorted out. So let's pick up a sword and put it in our sword hand. And then we can just put it in a couple of times. This is good for testing to see whether or not it is breaking with any of these other item slot indexes. Doesn't seem to be. We can save, take it out, and load, and it will be back in there, and everything works perfectly. So now our save and load system works for everything in the entire game, and you can start implementing this however you want. Again, the equipment system is a little bit iffy. If you're going to be using this in your own game, you probably want to redesign it and do with it as you need. This is just a basic framework of how you could implement an equipment system like this. Everything else is very like modularly useful, so that is very good. Anyway, that's the end of our inventory series for now. Anyway, this is the second chapter of it. If there's any more questions and enough of them pile up for me to start making even more follow-up videos, I will add them together into a third chapter. But for now, I think this second chapter is actually longer than the first one, so we're going to round it off here. Everything is now more or less production ready, I would argue. I'm going to be cleaning up a lot of this stuff. I'm going to be commenting the code, and then it will be ready for the patrons to download. By the time you're watching this, it will be ready for download, and hopefully has been for a while. So if you want to just get this and don't bother with setting everything up yourself, there's a link down below in the description for both patrons and YouTube members to just get this and just kind of roll with it. Thank you for watching, and we'll be back with the next fun thing. And a very big thank you to all of my Patreons. You can see them on screen right now. If you want to help out supporting the channel, there's a link down below in the description to the Patreon page. A huge thank you to my Cave Student tier supporters, Earl Monteval Erno, and my Cave Digger tier supporters, Sir J. Thomas,